Assalamu alaikum dear students. Since from last two lectures we are discussing the concept of relation. Today we are going to discuss the questions on this relation, that is exercise 2.2. Now the first question is, if A is set 1 to 14, that is A equals to 1 to up to 14, define the relation on R from A to A, that is R is here subset of A cross A. Here R is defined by R equals to those ordered pairs, those x, y's, such that 3x minus y is 0. That is, we have to consider those ordered pairs which are connected by the relation 3x or which satisfies 3x minus y equals to 0. We have to write the domain, codomain and range of this very relation R. Here R is defined on A. When we say that relation is defined on set A, this means that at that time this relation is subset of A cross A. It is given that R equals to those ordered pairs, that is those xy such that 3x minus y equals to 0, where x belongs to A, y belongs to A. Here the value of x can be from 1 to 14 and value of y accordingly from 1 to 14. When x equals to 1, put x equals to 1 in equation 3x minus y equals to 0, we get y equals to 3. When x equals to 2, y equals to 6. When x equals to 3, y equals to 9. And when x equals to 4, y equals to 12. Similarly, if we put x equals to 5, the value comes out to be 15. Y equals to 15, but y equals to 15 is not in A, so this means that we have to stop this substituting the value of x. Hence, in tabular form, R equals to 1 3 2 6 3 9 4 12. So the domain of equals to, now we have to find its domain. Domain means a set of first entries. Here set of first entries is 1 2 3 and 4. 1 2 3 and 4. So domain equals to 1 2 3 4. Range equals to set of second entries, that is 3 6 9 and 12. 3 6 9 and 12. And we have to find the codomain. We know that if R is a relation from A to B, that is R is the subset of A cross B, then codomain is actually second set. Here second set is simply A, because R is subset of A cross A, which implies that codomain of this very relation is simply set A. So in this way we find it the domain, codomain and range of this relation. Now second one is, we have to define a relation on set n where n is set of integers by R equals to those ordered pairs such that y equals to x plus 5, and it is given that here and x is less than 4, xy belongs to n. We have to write this relation in roster form or in tabular form. Then we have to find its domain and range. When R is relation on n, this means that R equals to n, R is subset of n cross n. And R is defined by those xy's such that y equals to x plus 5 and x is less than 4. Here when x is less than 4 and x is natural, which implies that x equals to 1, 2 and 3. We cannot put x equals to 4 because it is given that x is less than 4. So x equals to 1, 2, 3. When we put x equals to 1, we get y equals to 6. When x equals to 2, y is 7. X equals to 3, y is 8. So this is the tabular form of this very relation in tabular form of this relation. Domain means set of first entries is 1 2 3 and range equals to 6 7 8 set of second entries. Now its codomain is simply n, because here R is subset of n cross n. Now another one is we have to define a relation on A equals to 1 2 3 5, B equals to 4 6 9. Here A equals to 1 2 3 4, B equals to 4 6 9, or is defined, or is a relation from A to B defined by or of x equals to difference between x and y is odd. Here x belongs to this A, y belongs to this B, so we have to consider those ordered pairs, those x y, such that x minus y is odd number. We have to write this in roster form or in tabular form. Clearly here or equals to those ordered pairs such that x minus y is this odd. Now when we consider x equals to 1, y equals to 4, 1 minus 4 is, this is 3 or minus 3, so it is odd. 1 minus 6 is odd, 2 minus 9 is odd, 3 minus 3 4 is odd. Similarly 5 minus 6 is odd, 5 minus 6 is odd. Positive odd or negative odd, it doesn't matter, but we have to consider only the positives. And this odds, here we cannot put, or we cannot say that 2 4 ordered pair 2 4 2 4 this belongs to this, or because 2 minus 4 or 4 minus 2 is simply 2, that is even number. This means that this is the another form or the roster form or the tabular form of this very relation x y, such that difference between x and y is odd in tabular form. Another question is, if the relation is given as in visual representation as, or the relation whose visual representation is this. First set means set A equals to 5 6 7, second set is 3 4 5. There is a relation or. Under this relation or, 5 is related with 3. It is given that 5 is related with 3, 6 with 4 and 7 with 5. We have to express this this relation in tabular form as well as in tabular form. Tabular form means where we enlist the numbers. Here ordered, we have ordered pair 5 3 because 5 is related with 3, so it contains 5 3. 6 is related with 4, so it contains ordered pair 6 4. 7 is related with 5, so it contains ordered pair 7 5. So it has only 3 connections, or 3 connections between the elements of A and elements of B, so this means that it contains only 3 elements. Hence we enlist all the numbers. So this is the required tabular form of the given relation. Now its domain is set of first entries is 5 6 7, its range is 3 4 5, because it is range is simply set of second entries. Also in tabular form we can write this as xy, such that x belongs to A, y belongs to B, where x is simply given by y plus 2, because when we put x equals to y plus 2, when we put y equals to 3, x is 5. When y is 4, x is 6. When y is 5, x is 7, because these 3 5 6 7 are related with 3 4 5 through this very relation, where x belongs to this set A, this, and y belongs to this B. When you put y equals to 3, y equals to 4, y equals to 5, you will get x, the value of x, to be 5 6 7 respectively. So in this way we find in this way we wrote the above relation in tabular as well as in tabular form. Now another question is, determine the domain and range of the relation defined by x and x plus 5, where x belongs to 0 1 2 3 4 5. Here clearly we have to simply put, or firstly we will write this relation in tabular form, that is we enlist all the ordered pairs. For this we have to put x equals to 0, the corresponding value, that is at second place we will get 0 plus 5, that is 5. When x is 1, y equals to 1 plus 5. When x is 2, y equals to 1 plus 2. When x is 3, y equals to 3 plus 5. So in this way we enlist all the ordered pairs. When we enlist all the ordered pairs, so simply replace this domain equals to, clearly domain equals to set of first entries and range equals to set of second entries. So this is home assignment for you. Now the another question is, if a equals to 1 2 3 4 5, we have to define, and here the relation on this a is defined as xy such that y is divisible by x. We have to write this in roster or the tabular form and find its domain and range. Y divisible by x, this means that first divides second, x divides y, this means that y is divisible by 4. Like 4 is divisible by 2 means 2 divides 4. Now we have to write this where x belongs to 1 2 3 4 and y equals to 1 2 3 4. Clearly here 2 divides. Firstly 1 divides all the elements. 2 divides 4, but 2 does not divide 2. 2 does not divide 3. So we can say that 4 is divisible by 2 while 3 is not divisible by 2. Here this ordered pair divisible by x, xy belongs to where a equals to 1 2 3 4 6 means simply here 1 divides each and every element. So this means that 1 1 1 2 1 3 1 4 1 6 belongs to this, because 6 is divisible by 1, 5 is divisible by 1. Similarly 2 2 belongs to this because 2 divides 2, 2 4 divides 2, 2 divides 4. So in this way you can find all the numbers like 2 6 3 3 3 6 and 6 6. Clearly its domain is 1 2 3 4 5 6 set of first entries, and range equals to set of second is again 1 2 3 4 6. Write r equals to x and x cube where x is prime less than 10. We have to write this relation in roster form. Clearly those primes which are less than 10 are 2 3 5 7. So we have only 4 primes which are less than 5, this is 10. Now we have to consider the set as x belongs to 2 3 5 7. Clearly the relation is defined by x and x cube, so prime and prime cube. So r equals to first prime is 2, that is 2 into 2 cube, that is 8. 3 into 3 cube, that is 27. 5 into 5 cube, that is 125. Similarly 7 into 7 cube. So this is the required relation in the tabular form. If a equals to x y z, b equals to 1 2. So number of elements in a is 3, number of elements in b is 2. We have to find the number of relations from a to b. Firstly find the number of elements in a cross b, it is 6. Then the number of relations in a cross b is simply 2 to the power 6. That is, in this way you can find the number of relations. The last one is, let r equals to xy such that x minus y is integer, where xy belongs to z means set of integers. Find its domain and range. Find its domain and range. You know that we have to consider those ordered pairs whose difference of first and second terms is integer. You know that difference of integer minus integer is always integer. So this means that when we consider any integer at the first and the second place, it belongs to this R. So clearly it contains each and every ordered pair. Hence from integers. So this means that domain of this very relation equals to range equals to simply set of integers. So in this way we complete the exercise. Inshallah, I hope that you will understand this, and from tomorrow we will discuss the another topic, that is the functions. So thank you.